Let us start with the relations. Let A and B be any two set. We define a binary relation from A to B, which is a subset of A cross B. Let us give one example for a binary relation. I am taking two set A equal to 0, 1, 2, B equal to A comma B. Then the set of ordered pairs 0, A, 0, B, 1, A and 2, B. Here, since the ordered pair 0, A is present, we say that 0 is related to A, but 1, B is not in the relation. So 1 is not related to B. We can represent the relation as a diagram. Here 0, 1, 2, A, B. 0 is related to A, 1 is related to A, 2 is related to B. I have represented that using an arrow diagram. Similarly, we can represent them in a matrix form also. If you have a relation, I have put a into mark. If you don't have a relation, I have left the space empty. Note that a relation on a set A is a subset from A cross A. Now let us see the properties of relation. There are four properties: reflexive, symmetric, antisymmetric, and transitive. First, let us see what we mean by reflexive. A relation R on a set A is called reflexive if A, A belongs to the relation R for every element A belongs to the set A. Let us give one example for reflexive. A equal to 1, 2 and 3. We define two relations R1 and R2. Here R1 consists of ordered pairs 1, 1, 1, 2, 2, 2 and 3, 3. R2 consists of ordered pairs 1, 1, 2, 3 and 2, 2. R1 is reflexive since 1, 1, 2, 2 and 3, 3 is present in R1. But R2 is not reflexive since 3, 3 does not belongs to R1. Next property is symmetric. A relation R on a set A is called symmetric if B, A belongs to R whenever A, B belongs to R for all A, B belongs to A. Let us give one example for the property symmetric. A equal to A, B and C. We are defining two relations R1 A, C, A and B, and R2 A, C, A, B and B, B. Here A, C is present and C, A is present in the relation R1. So therefore R1 is symmetric. R2 A, C and C, A is there, but B, A is not there in the relation R2. So R2 is not symmetric. Next property is antisymmetric. A relation R on the set A is called antisymmetric for all A, B belongs to set A. If A, B belongs to R and B, A belongs to R, then A equals B. We can give an example for antisymmetric. R1 equal to 2, 1, 3, 1, 3, 2 and 4, 2. R2 consists of ordered pair 3, 4. Here both R1 and R2 are antisymmetric. In the relation R1, 1, 2 is not there, 1, 3 is not there, 2, 3 is not there, 2, 4 is not there. Therefore, it is antisymmetric. Similarly, 4, 3 does not belong to R2. Therefore, it is antisymmetric. Next property is transitive. A relation R on the set A is called transitive if whenever A, B belongs to R and B, C belongs to R, then A, C belongs to R for all values of A, B, C belongs to R. R1 consists of ordered pairs 1, 1, 2, 1, 2 and 2, 2. Take the set of ordered pairs 2, 1 and 1, 2. Here, when we apply this relation transitive, 2, 1, 2 implies 2, 2. It belongs to R1, therefore it is transitive. Any relation which satisfies reflexive, symmetric, and transitive, we call the relation as equivalence relation. Here, R1 satisfies reflexive, symmetric, and transitive. Since 1, 1, 2, 2, 3, 3, and 4, 4 is there in R1, therefore it is reflexive. Since 1, 2, and 2, 1 is there, therefore it is symmetric. 1, 2, and 2, 1 implies 1, 1, so therefore it is transitive. Therefore, R1 is equivalence relation. Let us give an example for reflexive, antisymmetric, and transitive. R1 consists of set of ordered pairs A, B, B, C, A, C, B, B, C, C, and D, D. Here R1 is reflexive, antisymmetric, and transitive. Here, since C, A, C, B is absent in R1, we call it as a poset since it is antisymmetric.